What if I told you that in our galaxy there are at least 100 billion stars, and that many of them have planets that could harbor life? Then where the hell is everybody? This simple question led one of the greatest physicists of the 20th century to formulate one of the most disturbing paradoxes in modern science. Hello, cosmic explorers. Welcome back to Cosmic Frontiers. Today, we're going to dive into one of the most fascinating mysteries that challenges everything we think we know about life in the universe, the Fermi Paradox. But before we begin this cosmic journey, I want to ask you something. Have you ever looked at the night sky and wondered if someone, somewhere among those countless stars, is looking back at you? Well, today we're going to explore why this question is much more complex and unsettling than it seems. And if you're new here, welcome to our community of cosmic explorers. We're on an incredible mission to reach 1,000 subscribers while unraveling the universe's greatest mysteries together. So hit that subscribe button and join us on this journey of cosmic discovery. Now, let's dive into this mind-bending paradox that has been keeping scientists awake at night for over 70 years. It all started in 1950 during a casual lunch at Los Alamos National Laboratory. Enrico Fermi, the brilliant physicist who helped create the atomic bomb, was chatting with colleagues about UFO reports that were popular at the time. Suddenly, in the middle of the conversation, Fermi asked a question that would echo through the decades. Where is everybody? This wasn't just casual curiosity. Fermi had done some quick mental calculations, and the numbers were staggering. Our galaxy is about 13.6 billion years old. It contains hundreds of billions of stars. Many of these stars have planets. And if life emerged on Earth, why wouldn't it emerge elsewhere? But here's where it gets really interesting. If an advanced civilization had emerged just a few million years before us, which is practically nothing in cosmic terms, they would have had enough time to colonize the entire galaxy. Think about it. We went from the first airplane to landing on the moon in just 66 years. Imagine what a civilization could accomplish with millions of years of head start. Let me put this in perspective with a simple analogy. Imagine our galaxy as a giant city with 100 billion houses. Earth is just one of these houses. Now, if life is common in the universe, many of these houses should be inhabited. And if intelligent life develops, some of these inhabitants should have become so advanced that they could travel from house to house, leaving traces of their presence everywhere. But when we look around our cosmic neighborhood, we see ... nothing. No signs of mega-engineering projects. No radio signals from advanced civilizations, no evidence that anyone has ever visited our solar system. It's as if we're living in a ghost town of cosmic proportions. This is the heart of the Fermi Paradox, the contradiction between the high probability that extraterrestrial life exists and the complete lack of evidence for it. Now, scientists have proposed dozens of solutions to this paradox, and each one is more fascinating and terrifying than the last. Let's explore the main categories. First, we have the rare Earth hypothesis. Maybe life isn't as common as we think. Perhaps the conditions that led to life on Earth are so specific, so incredibly unlikely, that we might be one of the few, or even the only planets where complex life emerged. Think about all the cosmic coincidences that had to align for us to exist. The perfect distance from the Sun, a large moon to stabilize our orbit, Jupiter acting as a cosmic vacuum cleaner, protecting us from asteroids, plate tectonics to regulate our climate. Maybe we won the cosmic lottery, and tickets are extremely rare. But there's an even more unsettling possibility, the Great Filter hypothesis. This suggests there's some evolutionary step that's nearly impossible to overcome. Maybe it's the jump from simple to complex life. Maybe it's the development of intelligence. Or maybe, and this is the scary part, the filter is ahead of us. What if civilizations tend to destroy themselves shortly after developing advanced technology? Think about it. We've had nuclear weapons for less than 80 years, and we've already come close to using them multiple times. We're changing our planet's climate at an unprecedented rate. Maybe every civilization reaches a point where their technology becomes powerful enough to destroy them, and very few make it through. Another possibility is that advanced civilizations are deliberately hiding from us. This is called the zoo hypothesis. Maybe there's some kind of galactic federation that has decided to let us develop naturally, without interference. We could be like animals in a cosmic zoo, observed but not contacted. Or perhaps advanced civilizations have transcended physical reality entirely. Why explore the galaxy when you can create perfect virtual worlds? Why build Dyson spheres around stars when you can simulate entire universes in quantum computers? Maybe advanced civilizations turn inward rather than outward. There's also the possibility that they're here, but we just don't recognize them. Imagine trying to explain the internet to an ant. The ant might walk right over a fiber optic cable and never realize it as part of a vast communication network. Maybe advanced alien technology is so far beyond our understanding that we can't even perceive it. But here's where it gets really mind-bending. What if time itself is the answer? Our universe is 13.8 billion years old, but it could continue existing for trillions upon trillions of years. From a cosmic perspective, we might be incredibly early to the party. Maybe we're among the first intelligent civilizations to emerge, and the galaxy will be teeming with life billions of years from now. Now, you might be thinking, but what about all those UFO sightings and alien encounters? Well, here's the thing. Extraordinary claims require extraordinary evidence, and so far, despite decades of investigations, we haven't found any conclusive proof that we've been visited by extraterrestrial intelligence. That doesn't mean we should stop looking though. In fact, we're looking harder than ever. Projects like SETI continue scanning the skies for radio signals. The James Webb Space Telescope is analyzing the atmospheres of exoplanets, looking for biosignatures, and we're discovering new potentially habitable worlds almost every week. But here's what makes the Fermi Paradox so profound. Every possible solution tells us something fundamental about our place in the universe. If we're alone, we're incredibly special and bear enormous responsibility as the universe's only known conscious observers. If we're not alone but civilizations tend to destroy themselves, we need to be very careful about our future. If advanced civilizations are hiding from us, we might not be ready for contact. The paradox also raises deep questions about the nature of intelligence and consciousness. Maybe intelligence as we understand it isn't the end goal of evolution. Maybe there are forms of consciousness so alien to us that we wouldn't recognize them even if we encountered them. What's particularly fascinating is that the Fermi Paradox might be self-resolving. As we develop more advanced technology and expand our presence in the solar system, we might finally detect signs of other civilizations, or we might become the advanced civilization that others wonder about. Recent discoveries have made the paradox even more intriguing. We now know that planets are incredibly common. Nearly every star has them. We've found water on Mars, organic molecules on Titan, and potentially habitable exoplanets in the habitable zones of nearby stars. The building blocks of life seem to be everywhere, which makes the silence even more puzzling. Some scientists argue that we haven't been looking long enough or in the right ways. SETI has only been seriously searching for about 60 years, a cosmic blink of an eye, and we've been assuming that alien civilizations would use radio waves like us. But maybe they've moved on to quantum communication or technologies we haven't even imagined yet. There's also the possibility that life is common, but intelligent life is rare. Maybe most planets develop simple microorganisms that never evolve into complex, technological civilizations. Earth might be unusual not because it has life, but because that life became intelligent and technological. But perhaps the most humbling aspect of the Fermi Paradox is that it reminds us how much we don't know. We're trying to understand the behavior of hypothetical civilizations that might be millions or billions of years more advanced than us. It's like an ant trying to understand human civilization. The concepts might be fundamentally beyond our current comprehension. The paradox also highlights the importance of our search for life. Every new exoplanet we discover, every biosignature we detect, every radio signal we analyze brings us closer to answering one of humanity's most profound questions. Are we alone? And here's something to consider. Maybe the answer to the Fermi Paradox is just one thing. Maybe it's a combination of factors. Maybe life is rarer than we think, and civilizations tend to destroy themselves, and advanced species prefer to stay hidden. The universe is complex enough that multiple explanations could be true simultaneously. What makes this even more fascinating is that we might be living through the resolution of the paradox right now. In the next few decades, our technology will become sophisticated enough to detect biosignatures on exoplanets, analyze their atmospheres in detail, and possibly even detect technosignatures, signs of alien technology. We're also becoming a more detectable civilization ourselves. Our radio and television broadcasts have been spreading into space for about a century now. Any civilization within 100 light-years could potentially detect us. In cosmic terms, we've just started announcing our presence to the galaxy. The Fermi Paradox also forces us to think about our own future. If we're truly alone, then the responsibility for preserving and spreading consciousness throughout the universe falls entirely on us. We become the universe's way of understanding itself. But if we're not alone, then we need to think carefully about how we want to present ourselves to the cosmic community. Some scientists argue that we should be more cautious about broadcasting our location. If the reason we don't see other civilizations is because something destroys them when they become detectable, maybe we should stay quiet until we're more prepared for contact. But others argue that the potential benefits of contact far outweigh the risks. Imagine what we could learn from a civilization even just 1,000 years more advanced than us. They might have solved problems we're still struggling with: climate change, energy production, disease, maybe even aging and death. The paradox also raises questions about the nature of consciousness and intelligence. We tend to assume that intelligence naturally leads to technology and space exploration, but maybe that's just our particular path. Maybe other forms of intelligence develop in completely different directions. What if consciousness can exist in forms we haven't even considered? Maybe there are intelligent gas clouds in space, or conscious quantum fields, or digital minds that exist in the cosmic background radiation. We're looking for intelligence like ours, but maybe the universe is full of minds so alien that we can't recognize them. And here's a mind-bending thought. What if the Fermi Paradox itself is the answer? What if every civilization eventually discovers this paradox and realizes that the universe seems empty, and this realization fundamentally changes how they develop? Maybe the act of asking, "Where is everybody?" is itself a crucial step in a civilization's evolution. The paradox also connects to some of the deepest questions in physics and philosophy. Are we living in a simulation? If so, maybe the programmers didn't bother to populate the rest of the universe with other civilizations. Are there multiple universes? Maybe each universe only gets one intelligent species. Is consciousness fundamental to reality? Maybe the universe needs conscious observers, and we're fulfilling that role. Recent developments in artificial intelligence add another layer to the paradox. If we can create artificial minds that are more intelligent than us, maybe every civilization goes through a technological singularity where biological intelligence is replaced by artificial intelligence. Maybe the galaxy is full of AI civilizations that have no interest in contacting biological species like us. Or maybe the development of AI is itself part of the great filter. Perhaps civilizations that create artificial intelligence tend to be replaced or destroyed by their creations, and very few successfully navigate this transition. The Fermi Paradox also makes us think about timescales. Human civilization has existed for only about 10,000 years. We've had radio technology for about 130 years. In cosmic terms, we've been detectable for essentially zero time. Maybe civilizations exist, but their technological phases are so brief that the chances of two civilizations being detectable at the same time are incredibly small. Imagine if technological civilizations typically last only a few hundred years before either destroying themselves or transcending physical reality. The galaxy could have hosted thousands of civilizations, but they were separated by millions of years. We might be like ships passing in the cosmic night, never quite overlapping in time. But here's what I find most fascinating about the Fermi Paradox. It's not just about aliens, it's about us. It's about our place in the universe, our future, and our responsibility. Every possible solution to the paradox tells us something profound about the nature of life, intelligence, and consciousness. If we're alone, we're the universe's only known way of understanding itself. We're incredibly precious and bear enormous responsibility for preserving and spreading consciousness throughout the cosmos. If we are not alone but hidden, we need to think carefully about when and how we make contact. If civilizations tend to destroy themselves, we need to be very careful about our own future. The paradox also reminds us that we're still in the very early stages of our search for extraterrestrial life. We've only been seriously looking for a few decades, and our technology is still primitive compared to what we'll have in the coming centuries. Maybe the answer to "where is everybody" is simply we haven't looked hard enough yet. But regardless of the answer, the search itself is transforming us. It's making us think more deeply about life, intelligence, and our place in the cosmos. It's driving technological development and scientific discovery, and it's uniting humanity around a common question that transcends national, cultural, and religious boundaries. So, cosmic explorers, what do you think? Are we alone in the universe, or is there something else going on? Do you think the Great Filter is behind us or ahead of us? And if we do make contact with an alien civilization someday, how do you think it will change humanity? Share your thoughts in the comments below. I love reading your theories and perspectives on these cosmic mysteries. And if you have ideas for other paradoxes or mysteries you'd like us to explore, let me know. Your suggestions help shape our journey through the cosmos. If this video expanded your cosmic perspective and made you think differently about our place in the universe, give it a thumbs up and share it with someone who also wonders about our cosmic loneliness. Every share helps us grow our community of cosmic explorers and gets us closer to our goal of 1,000 subscribers. And remember to hit that subscribe button and ring the notification bell so you never miss our cosmic adventures. We're rebuilding something special here, a community of curious minds exploring the universe's greatest mysteries together. In our next video, we'll explore another fascinating enigma that challenges our understanding of reality. Until then, keep looking at the stars and wondering, is someone looking back? The universe is vast, mysterious, and full of possibilities we can't even imagine yet. And maybe, just maybe, we're not as alone as the silence suggests.